All right, welcome back, students. Today we're going to learn another derivative technique, and before we learn it, we're going to go ahead and do these two problems, number one with the quotient rule and number two with the product rule, and then we're going to learn the new technique which actually we'll be able to use to do these same two problems a different way. So number one, let's use the quotient rule to find the derivative. So we have dy dx equals the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And then let's simplify that. So we have the opposite of 12x cubed minus 2 over, forgot my squared, didn't I? Over 3x to the fourth minus 2x quantity squared. For now, I'm just going to leave it like that. We could multiply the negative through the numerator, which would be a good thing to do, but I'm going to wait and hold off until we see the second method. Problem number two. So let's go ahead and rewrite the function as 5x plus 7 times 5x plus 7. We could multiply that out using the FOIL method before we differentiate, but I'm actually just going to apply the product rule, and we get the first times the derivative of the second plus the second times the derivative of the first. And that can be simplified, but for reasons you'll understand later, what I'm going to do is say that we have two of these things. So we have 2 times 5, well, I'm even going to write it like this. We have 2 times 5x plus 7 to the first times 5. You'll understand why I wrote it that way when we get to our next rule. Okay, so we're on notes number 25, and the title is the chain rule. And the chain rule is the process for finding the derivative of a composition of functions. A composition is where you have a function inside a function, so f of g of x. Now you could have more than two layers or more than two links in your chain, you could say. You could have any number of them, but the idea is you have one or more functions inside other functions. And so I'm not going to prove this rule to you, but I'm just going to give it to you. Unfortunately, sometimes we just don't either have the math tools for the proof or we just don't have the time. So here's what the chain rule tells you to do. If you have two layers, you have an outside layer f and an inside layer g, you're going to take the derivative of the outside and multiply it by the derivative of the inside. So that's our casual way of putting it. Looking at it in terms of math notation, we're finding the derivative, so that's what the little prime symbol means, of f of g of x. And so here we see the derivative of the outside, that would be f prime, times the derivative of the inside, that would be g prime. But what I want you to notice here is that inside f prime is still the inside function. So it's not just an x there, but it's whatever the inside function is. And that will make more sense when we do our examples. And then if we look at that expanded to more than two layers, so here we have f of g of h, and we're finding the derivative, that's what the prime is. So we have f prime, the derivative of the outside, times g prime, the derivative of the middle, times h prime, the derivative of the very inside. And every time we take a derivative, whatever was inside that function is still there. So inside of f, we had g of h. And inside of g, we had h. And inside of h, we had x. So that's all still there. Okay, so basically right now I just want you to think of it like this. The derivative of the outside times the derivative of the inside. Okay. Now, back to the two problems we did in the warm-up. I'm going to rewrite number one as y equals 3x to the fourth minus 2x to the negative 1 power. Now you can see it has an inside function. The inside function is 3x to the fourth minus 2x, and the outside function is the -1 power function. If that function was just by itself, it would be like f of x equals x to the -1, and then the inside function is g of x equals 3x to the fourth minus 2x. So putting those together, we get our function y. So for the derivative, what we're doing is using the chain rule, we're going to take the derivative of the outside function and multiply it by the derivative of the inside function. So the outside function is the -1 power function. Bring down the -1 and raise whatever you have to the -2. And what we have is 3x to the fourth minus 2x. So that part there is the derivative of the outside. Then we're going to multiply it by the derivative of the inside. Sorry, that was hard to say. The derivative of the inside. And to do that, we're taking the derivative of 3x to the fourth minus 2x, and that would be 12x cubed minus 2. Okay, so once we've done that, maybe there's some simplifying to do. Now what I'm going to do is just show you that we get the same answer we got using the quotient rule. So I'm going to take the -1, leave it on the outside. We have 12x cubed minus 2, and then because of the negative exponent, I'm going to move this thing to the bottom. And you'll recall that that answer is exactly the same as the answer we got earlier in the warm-up. See, right there. And then taking a look at number 2, also from the warm-up, and applying the chain rule, we have f prime of x is the derivative of the outside times the derivative of the inside, where the outside function is the squaring function. So the outside function is x squared, or something squared, and the inside function is 5x plus 7. So the derivative of the outside, bring down the 2, and raise the inside to the first, and then multiply that by the derivative of the inside. The derivative of 5x plus 7 would be 5. And you'll recall that that's what we had for our answer when we did number 2 earlier. Now you wouldn't leave it like this, you would just write it as 10 times 5x plus 7, or you could even just distribute the 10, might as well. Okay, so let's use the chain rule a couple more times, and we're going to start using it on problems that we couldn't otherwise do. So even though we know the derivative of the sine function, and we know the derivative of 2x, we couldn't previously find the derivative of sine of 2x. Now notice this is not a product. This is not sine times 2x. This is sine of 2x. So you have an inside function, 2x, and you have an outside function, sine. So using the chain rule, the derivative of the outside, so the derivative of sine is cosine. So we have cosine of 2x times the derivative of the inside. The inside is 2x, so its derivative is 2. So then we'll just write that answer as 2 cosine 2x. And then for number 4, the inside function is 3x squared minus e to the x. The outside function is the cubing function. So we'll take the derivative of the outside, which is to bring down the 3 and change the exponent to 2. And then we'll take the derivative of the inside. So the derivative of 3x squared is 6x, minus the derivative of e to the x is e to the x. So we have that. And I suppose we could maybe simplify if we felt like it. We could multiply the 3 by 6x minus e to the x, but I would say that's pretty much an optional step. So I would be okay with leaving it like this. Let's see what else we have. Okay, 3 more, and that's going to be it. Now, it looks like I didn't give you any examples of problems where you have multiple or more than 3 layers, so maybe we'll do one of those before we're done. Okay, number 5, y equals sine cubed of x. Remember, this is the same thing as the sine of x quantity cubed. So the derivative would be the derivative of the outside. The outside is the cubing function. Bring down the 3 and change the power to 2, times the derivative of the inside. The inside is sine of x, and its derivative is cosine x. Now, I wouldn't write my answer this way because we don't usually write sine of x quantity squared, but instead we write sine squared x. So 3 sine squared x cosine x. Number 6, the outside function is the square root function and the inside function is the x squared plus 4. But let's rewrite this as x squared plus 4 to the 1/2 power so we can use our power rule. So the outside function, the 1/2 power function, its derivative is bring down the 1/2 and raise the inside to the negative 1/2. And then multiply by the derivative of the inside, and the derivative of x squared plus 4 is 2x. So then let's multiply the 1/2 and the 2x, and then because we have a negative exponent, let's move that part down to the bottom. So 1/2 times 2 is 1. So we have x over x squared plus 4 to the 1/2. But let's change, sorry, I'm stumbling over my words today. Let's change that back to a square root, x over the square root of x squared plus 4. Okay, and then for number 7, we actually did this problem a while back. I don't know if you remember, but the day we learned the product rule, we took this and we said this is the same as e to the x times e to the x times e to the x, and we used the triple product rule on it. But now we actually don't have to do that. What happened when we used the triple product rule is we did the first times the second times the derivative of the third plus the first times the third times the derivative of the second plus the derivative of the first times the second times the third, and when you simplify all that together you get 3e to the 3x. Maybe you remember that. But if we're going to use the chain rule, recognize that the outside function is the e to the x function and the inside function is the 3x function. So the derivative of the outside, the derivative of e to the something is e to the something times the derivative of the inside. The derivative of 3x is 3. So there you go, 3e to the 3x. Much simpler than having to use the triple product rule. Okay, so let me squeeze in a bonus problem for you. Since I didn't give you one that had 3 layers, I think we ought to do that. Suppose we have, suppose we have cosine squared of e to the x. I should call that something. Let's call that y. So remember, this is the same as cosine of e to the x all squared. So the outermost layer is the squaring function, the middle layer is the cosine function, and the inside layer is the e to the x function. I'm even going to change that. Instead of e to the x, I'm going to make it e to the 2x. So actually we have 4 layers now because the innermost layer is 2x. So in this chain rule we're going to have 4 things multiplied together. So the derivative is going to be, first, the outermost part is the squaring, so bring down the 2 and raise the cosine of e to the 2x to the first. Of course you don't have to write the 1 there. When you raise something to the first, we don't write the 1. I'm just doing that to prove the point. Next layer is cosine, and the derivative of cosine is negative sine. So we have negative sine of e to the 2x. Whatever was in there before is still in there now. Times, and then the derivative of e to the 2x. So think of it as the derivative of e to the something is e to the something, times the derivative of 2x, 2. Okay, so what can we simplify? What can we combine? We have the 2, we have the negative 1, and we have, oops, right there, and we have the 2. So let's call that negative 4. And then might as well write the e to the 2x next, and then I'll write the cosine of e to the 2x and the sine of e to the 2x. Okay? So that's the chain rule. We're actually going to work on it some more next time. Get into some more complicated examples. So just for today, we're doing these, 6 problems? And the book's directions might be confusing to you. It talks about using the general power rule and the shifting and scaling rule. We're just talking about the chain rule here, so you can ignore the directions and use the chain rule to find your answers. Thank you, everybody.